Imagine trying to bake a cake, but your recipe is magically locked to one specific brand of oven, located in one specific city. If you pack up and move to a new house with a different kitchen, all those careful temperature settings and baking times suddenly become completely useless. To get that exact same cake in your new home, you'd have to figure out the measurements and write the entire recipe out all over again from scratch. A brilliant recipe does not do you much good if it is permanently trapped inside a single, inflexible environment. Back in the early 1990s, older languages like C and C++ suffered from this exact problem. In the software world, this is known as being platform-dependent. If a programmer wrote a piece of software for a Windows machine, that code would fail if you tried to run it on an Apple computer. Developers had to constantly rewrite their hard work to fit different hardware. As you see in this photo of an early IBM system, enterprise computers were massive, highly distinct machines, each requiring its own specific, tailor-made code. When completely different personal computers, like this Apple Macintosh, filled offices and homes, rewriting software for every machine became an unsustainable nightmare for developers. In 1991, a team at Sun Microsystems, led by James Gosling, looked at this mess and realized developers needed a universal translator. 4 years later, they released that solution to the world, Java. To understand how Java fixed this, we have to look at how older languages worked. C and C++ used a tool called a compiler to translate a programmer's code straight into a language that only one specific machine could read, resulting in something like a .exe file. A .exe file is a dead end. It is a finalized recipe that is baked entirely for one specific operating system and cannot be adapted for any other hardware. This animation shows Java's core innovation. Instead of going to a finished file, Java uses a two-step process. It translates raw code halfway into a generic format called bytecode. This bytecode is stored in a .class file, waiting for the final step. By stopping halfway and avoiding an immediate commitment to a specific piece of hardware, Java keeps the software flexible enough to go anywhere. But that brings up an obvious question. How does your computer actually read a language that is only halfway translated? It uses a special bridge on your computer called the Java Runtime Environment, or the JRE. Think of the JRE as a universal translator that understands both the software and your specific machine. This glowing container represents that translator, acting like an adaptable smart kitchen on your device. Upon receiving generic bytecode, it immediately adjusts. The JRE translates the recipe on the fly for your specific hardware, whether a mobile phone, laptop, or massive server rack. That combination, the generic bytecode paired with the adaptable JRE, is the secret behind Java's famous promise: write once, run anywhere. Beyond making code compatible, Java also tackled how safely programmers could build their software. In older languages like C and C++, developers had to manually wire up the computer's raw memory using things called pointers. This was a risky process, and one wrong move could easily crash the entire system. As this animation shows, Java completely removed those exposed pointers. It takes that dangerous wiring and hides it safely behind manageable, protective building blocks. Older languages also require developers to manually clean up that memory after a program finished running. That is a lot like being forced to wash every single dish by hand after hosting a massive dinner party. Java handles this through a feature called garbage collection. It acts like an automatic dishwasher, silently clearing out unused memory in the background so the programmer never has to worry about it. By hiding the dangerous wiring and automating the messy cleanup, Java established itself as a deeply secure and robust language. Because it works perfectly in so many different environments, Java was packaged into different menu sizes based on what a developer needs to build. There is the Standard Edition for learning fundamentals and building desktop applications, alongside the Enterprise Edition, which handles massive server-side business software. Sun Microsystems also released the Micro Edition, designed specifically to squeeze Java into tiny devices and early mobile phones. As you can see with these early smartphones, that micro-programming foundation ultimately paved the way for modern mobile operating systems that run the world today. All of these components work together to form a system that is much more than just a list of coding commands. Java functions as a complete, dynamic ecosystem that pairs an organized, human-friendly way of writing code with its own protective runtime platform. This system freed developers to focus entirely on what they wanted to build, letting the software handle exactly where it would run. So the next time you see that famous steaming coffee cup logo, you will understand the universal machinery humming right beneath it. Now that you understand how the kitchen works, head to our next video to write your very first line of Java code.